7.4, solving logarithmic equations and inequalities. So we have crossed out logarithmic inequalities, so we're just focusing on equations this year. So in order to solve the logarithmic equation, it's a similar process to what we were just doing in 7.3. A lot of times you're going to transfer or translate back to that exponential form, or you're going to be asking yourself the question, what exponent do I need to get from this base to get to this number? So in this case here, it's given me a base of 8, and it's given me an exponent of 4/3. We know that from the question, what exponent do I need to get from a base of 8 to get to x? And the answer was 4/3. So we need to figure out what would x equal. I would recommend that when you get to a point that you don't know how to solve any further, for example, you have log of a number, then you need to change to exponential form. And we can do that with the loop, we can do that with the question, we can do that with memorizing 7.3, but we are going to change to exponential form here. So I'm going to choose to use the loop. So start at the base, go around the equal sign, end at the number next to the base. 8 to the 4/3, because that's what my loop touches next, equals the number next to it. Well, now it's a much easier problem. I just have to type into my calculator. What is 8 to the 4/3? 16. So in logs, it's a pretty good rule of thumb that if you're stuck and don't know where to go from there, try switching to exponential form and see if you can solve further. So in this case, the base is 16. I'm going to go around the equal sign and end at the number next to it. So 16, it crosses 3/4 next, and it equals the number next to it, 16 to the 3/4. So my answer is just 8. Take a look at C. Now in C, if we change to exponential form, it may not be as helpful to us, but we can always give it a shot. It's asking from the base around the equal sign and at the number next to it. So 8 to the what equals 16. So in this case, it wasn't helpful because I can't get my exponent out, or I can't get my x out of the exponent without leaving it in logarithmic form. So what we can do is now I can maybe rewrite it as an exponential equation. Thinking back all the way to 7.2, when I had something that looked like this, I knew I had to find a common base. So the base that I could use is 2. And I know that 8 is 2 to the 3rd. I know that 16 is 2 to the 4th. So I have 2 to the 3 for 8 and 2 to the 4th for 16. And again, I'm going to plug in that exponent. We know that when the bases are the same, the exponent gets set equal to each other. So divide by 3 on both sides, and it equals 3. Let's change the next one over to exponential form. So I have the base around the equal sign, ending at the number next to it. 27 to the negative 1/3 equals x. Well, now I just have to input into my calculator. 27 to the negative 1/3, and that equals 1/3. Now in each of these problems, I had only a log, one log, and it was all by itself on one side. There's no numbers being added or subtracted to the log. There's no number being multiplied or divided by the log. I just had log of something equals something. And our strategy for solving that was change it to exponential form. You'll notice in number 3, though, it looks just a little different. I now have 2 logs. I have one log on the left, and I have one log on the right. So in order to solve this, we have to know that if I have a log with the same base on both sides, then I can set this part equal to each other. So I have x squared minus 10 equals 3x, and I can solve that out. This is a quadratic, so that means I'm going to have to subtract 3x from both sides. And to solve this, we're going to factor. What number multiplies to be negative 10 but adds to be negative 3? And that would be 2 and negative 5. Draw your box. X squared, negative 10, 2x, and negative 5x. I know x can come out, 2 can come out, x can come out, negative 5 can come out. So I have x minus 5, x plus 2, and set both of those equal to 0 so that x could be 5 or it could be negative 2. Now it's very important that when you're solving a logarithm that you always double check that when I plug it back in, it truly does work, because you cannot have the log of a negative number. So log of a negative number, that is something that is not allowed. So we always double check. If I plugged 5 back into the x squared minus 10, make sure you're not going to get a negative number. 5 squared minus 10, 15, we're good. 3 times 5, 15, we're good. Negative 2, plug back in. Negative 2 squared is 4. 4 minus 10, negative 6. That means that negative 2 cannot be a solution. It's extraneous. 5 is my only solution.